Hello friends, welcome to Learn Well Teach. Today our concept is subnets and route tables in AWS. So this is one of the most important topic as well as exciting topic. It's like for example, when you go to the highways, you see some, Bangalore left side, Hyderabad right side, or something straight. The same thing here in our network. It actually decides how the route table actually decides how the traffic will flow across the network, internally as well as externally. Internal in the sense in between instances, inside the VPC as well as to the internet, as well as from the internet to our EC2 instance. That's what the simple explanation. So let's, before going to that, let us see the components and the diagram what we have defined for now. Okay, so again we have the normal VPC. Here I have taken two availability zones, availability zone A, availability zone B, and we have one public subnet and public subnet B, and we have EC2 instance in public subnet A, and we have EC2 one EC2 instance in public subnet B, and we have one main route table. Okay, don't worry, people assume that we have one custom route table for each subnet, and what is this? This is the main route table and this is the router. Okay, the where traffic will flow. Let us explain case by case because there are different approaches, especially in AWS, because AWS evolves from a quite amount of years, right? It's not just hey, it is just designed in just 1 year. It has been evolving in multiple years. So that's the reason I have taken this concept called main route table, which has been here, for a couple of years. Okay, so let us define. Let's go to case number 1. Okay, here, okay, in the diagram it is showing 3 rows, but it's not 3 rows. I have assume that this is the main route table, and this main route table has only this route 10.0.0.0/16, which is target is local. Okay, now let us assume that I just put algorithm in the sense step by step process. We will go with steps. Okay, let's say for example, this main route table comes with VPC. Okay, let's say I created a VPC, and this main route table comes with this VPC. Okay, let's make sure about that part. Okay, now I want this EC2 instance to ping this EC2 instance. Okay, that's what our main intention is. Now, so as we mentioned before, to travel from this EC2 instance, this EC2 instance, it should have some route, right? And this is the route, local in the sense, and this, which means internally. Like for example, this is the arrow, right? So it will go this way and it will go here straight, and it will go again, and this will this route table will check whether the dedicated route is there or not. Then yes, it is showing some local. What destination is 10 dot. So yeah, so there is some. So basically, this IP address is defined by us. So yes, there is a route to connect to internal EC2 instances, and finally and automatically it will go to the EC2 instance. Okay, so the main route table is the local route. That's what I have said before. Okay, and this route table is this one I have defined here. Okay, assume I ping 10.10.1.14, which means the IP address of this instance. Okay, the IP address of this instance present in public subnet 2 in availability zone 2. Okay, yeah, it will check whether if there is a route to go to this address. Yeah, we can see 10.10.1.14 is a part of 10.0.0./16. What does it mean? It means basically this is the IP address for this whole VPC. This whole VPC, this is the IP address. Okay. Yes, so that's why I ping 10.10.1. I'm sorry, it is 14, not. Then automatically it will get the details of this EC2 instance, because there's a local route is present inside this network or VPC. Okay, so this is fine. This is a simple use case. Okay, now I want to ping Google from this EC2 instance. I want to ping Google. Then this case will come into picture. So my instance want to instance in public subnet A want to ping Google. Okay, now this route table, this main route table, you know, has two has a new route called internet gateway, and this represents the internet. Okay, whoever wants to connect to the internet, this is the IP address 0.0.0.0/0 is the way to go to the internet or outside VPC, and this internet gateway will connect to the internet. Okay, so from this it will go to this main route table. From main route table it will go to the internet gateway to internet. Why I put two arrows in the sense here? One arrow for local route, one arrow for internet gateway, just for representation purpose. That's it. Anyway, this diagram we already seen above. Only here improvement is we have added one more arrow so that it will go to internet gateway. Okay. Again, here one more observation is we haven't put any internet gateway for this public subnet in availability zone 2 or public subnet 2, whatever we define. Okay, now let us see some analysis catch points here. Okay, assume that Google IP address is 54.2.2.11.00. Okay, whatever it may be, I don't care. Be it's available Google or not, I don't care. However, in the internal earlier diagram we don't have the route to match the IP since it is just a machine, right? Yeah. Okay, so basically here this IP address, so what does it means is in the earlier diagram you don't have a route to go to the internet because it will first check here in the main route table. It is not present, then obviously it will not able to fetch the or ping the Google, right? That's what I meant to say here. So we should include 0.0.0/0 traffic to internet. That's what I already explained at the beginning. Okay, now I want to make sure this one, what does it mean? Wait, house clean no festival. In Telugu we call it as a Illu Kadagar Pandaga, which means if I clean the house, which means it doesn't mean a festival, which means it's not completely over. Now the attributes comes into play. Okay, you pinged the Google, that's fine, but you have to fetch back, right? You have to fetch back the details, right? To receive traffic back, our instances must have public IP. Okay, here what is meant to say is we have for every EC2 instance we have private IP because every EC2 instance is secured in public subnet, or every EC2 instance automatically you will get private IP for every EC2 instance by default. However, we need to assign public IP uh, to fetch the details of the internet. So by using private IPs we cannot connect to the internet. This is what the case number 3. We must have public IPs for each of the uh, EC2 instances. Okay, that's one of the main catch point to fetch the details from the internet. Okay, along with private IP we need to have public IPs for each of the EC2 instances. Whoever wants to connect to the outside world, again to fetch the details back, to get the traffic back. That's what I meant to say. I haven't put the traffic back here arrow, but yeah, that's what I was meant to say. Okay, so let us see the summary for now. Okay, VPC should have internet gateway accounts outside world, and the route traffic should be 0.0.0/0, which is standard. And to receive traffic we should have public IP to EC2 instances. That's what I was meant to say finally. Okay, that's fine. Now the final one where we use this one in the day-to-day life much more, dedicated route table, which is also called customized route table. Okay, so what is the difference between this diagram and this diagram? The main difference is here I have included a route table for each subnet, a route table for this subnet, a route table for this subnet. Here in this diagram I didn't include these route tables. What does it mean? Okay, let's see some note points I have written here. So basically when we create a subnet inside a VPC, all the subnets will actually route to main route table by default. Okay, that's a VPC, that's designed by software engineers of VPC. We can't do anything. Okay, but we cannot follow same rule for every subnet since each subnet is designed for special purpose, some for database, some for web servers. Okay, database servers has security issues and hence we cannot connect to the internet, and some servers have some other issues, and hence we should have our own routes dedicated to each subnet based on the requirement. That's where the custom route tables come into picture, and this one and this one. Okay, yeah. So my catch point here is whatever route, my catch point here is we should have a separate route table for the separate subnet. That's what main purpose of route tables, customized route tables is. Okay. Now, whatever route table may be, whether it is main route table, customer route table, local route must be present, which means even for main route table or even for customer route table, to communicate EC2 instance internally, this is mandatory, which means this one is completely mandatory to communicate these two instances inside the VPC, inside this VPC. Okay, that's one of the catch point, note point. Now, when we create a customer route table, connection between subnet and main route table will be terminated, which means earlier, if you can see this one, it is going to the main route table, it is going to internet gateway. Okay, here what I was meant to say is, here it is not going to the main route table. Okay, here it is directly going to the internet gateway. Here it is directly going to the router. Okay, for local connection, here if you see this, for go to local connection, this is the route map, and here this is the route map to connect to internet gateway. So here we can say, whenever we create a custom route table, connection between subnet and main route table will be terminated. That's what I was. These are main key points in connection with subnet and route tables. Both are interlinked. We cannot separate it. Let's have a summary of what we have done so far. Some route table and subnets. I can say some route table and subnets. Contains rules. Route table contains rules to route traffic in and out of subnets and VPC. In and out. To go to the internet as well as to travel, communicate internally, you should set some rules. Okay. Every VPC comes with main route table. Main route table comes with main route, and this is the main route. Okay. Which allow communication between machines. Without this one, like machines cannot communicate each other, right? Route table is just a route table is the rules defined at the VPC level. Okay. Custom route table defined at the subnet level. Okay. Yeah. We have custom route table, subnet level. Okay. EC2 will follow the rules within subnet. Yeah. Whatever we put the rules, the EC2 will follow that one. Okay. It is not a like human made, right? It's just a machine. We define the rules and it will follow the rules defined by us. If no route table is defined, you submit the main route table. Yeah. If I don't give any customized route tables, then I obviously need to follow the main route table, which I defined in the very first diagram. This one. Okay. Thank you guys. See you. Hope you enjoyed it. Maybe in the coming videos, I will explain much more detail in much more concepts, in much more use cases. Okay. So just stay tuned. This is just the beginning. You have lot to see in the future. See you guys. Thank you.